Hello and welcome to this session. In our earlier sessions, we had seen the preliminary concepts pertaining to database management systems, various types of database management systems, and how each and every database management system is differ with the other database management systems. And we had seen the popular relational database management system, and in that particular thing we had seen the preliminary concepts like what is relation, what is a column, what is a tuple, what is a row, which is called as a key, records. So likewise we had touched upon several terminology. So in this particular session, let us concentrate on various key constraints in relational database management systems. So let us start with relational schema. What is relational schema? It is nothing but you had designed one entity relationship diagram which comes under the conceptual design, that is a simple blueprint wherein which you had identified the entities, you had identified the attributes or characteristics pertaining to each and every entity, and then you had looked upon the meaningful relationship between one entity with the other entity, and even you had mapped the type of relationship, is it one to one, one to n or n to n. So in this way your ERD, the map or else the first step of the database design is ready. Then in this particular thing you had prepared the relational schema also, like you had converted the complete ER diagram in the form of a relational schema. Relational schema is nothing but you are identifying the relation name with various columns or else various attributes. For example, here I had selected salesperson as the relation name, social security number, name, year of join and department as the attributes or else as the column names. So this particular relation we can represent it in the form of a table, like salesperson will become the table name, SSN, name, year of join and department will become the columns in the table. Likewise another example I had given, student with student enrollment number, name, major and then date of birth, and then book, ISBN, book title, publisher, author, year of publication. So here you can see these are various relations or else the schema is called as the relational schema. Suppose if you represent the relational schema for the total database, then it is called as database schema, the complete database schema for the backend of that company. So relational DB and relational DB schema is nothing but it is a complete collection of relations with the distinct relation names. So you will identify the database name, and along with that database name whatever the relations that you want to store under that database name, you will be identifying and making them as the relations to that particular DB schema. Then the relational database schema is a collection of schemas for the relations in the database. Let us see as an example. This is an example for a company. So here I had identified various relations. One is employee, department, department locations, works on, project and dependent. So these are the relations, 6 relations we had identified. Along with each and every relation we had identified the attributes also. So what needs to go in order to represent an employee table we had identified and we had given in the form of an attribute name, F name, first name, last name, SSN likewise. So for each and every relation we had identified the attributes also. And here you can see for each and every relation even we had identified the keys also. So in order to retrieve the employee record, we can identify here the SSN, social security number, as the primary key. What is meant by a primary key? Later on in this session we will see. In order to access the record of department, you can identify depart number as a key. Likewise, wherever there is a requirement in order to retrieve the unique records in the tables those are existing in the database, we will identify the key, and depending upon the key we can retrieve the record. So, here we can induce the constraints also. So, various restrictions on data can be specified on a relational database in the form of constraints. For example, if you take the case of student ID, so in the student table with student ID, same student ID, under the same student ID, two different names can't be stored, which is against to the database management system. Why? Because student enrollment number itself uniquely identifying each and every record. So, with the same enrollment number we can't store two different students. So, we had introduced some sort of constraint, a kind of restriction, wherein which under the student enrollment number we can't store same like different names of the students under the same number. Likewise, if you see there are two persons with same name, then in the student name it can be allowed with the two different student IDs. So, this is possible. So, under these particular restrictions there are several categories wherein which we can discuss one by one. First one is the domain constraint, key constraints, integrity constraints, referential integrity, that is a foreign key, and then there are other forms, the data dependencies and the functional dependencies. So, in this way we can induce, these are the various categories wherein which we can induce the different constraints or the restrictions into the database. Let us start with the domain constraints. Domain constraints specifies that the value of each attribute A must be an atomic value from the domain. Suppose if you are identifying one domain or else one attribute, along with that attribute you will be identifying the data type also. Suppose if I am taking the case of student enrollment number as a column or else as an attribute, for that student enrollment number I will be identifying the data type also, integer or anything. So, for each and every attribute we have to identify the key value data type, as well as it should contain only one atomic value. Each and every attribute must contain one value only. Suppose if you have a column contact, wherein which in the database if it is allowing to store email address as well as the telephone number or as well as the mobile number, it should not permit. Why? Because in that particular contact column it is meant to store only one atomic value. Either you can store, depending upon the data type we had selected, either it can store the mobile or else it can store the email, or else you can split that particular column into two columns. You can extend that table and you can give one field as one field for the mobile number and the other field for the storing of email address. So, domain constraints specify that the value of each attribute A must be an atomic value from the domain. Domain means data type here. Then comes the integrity constraints. It is a condition that is specified on a database schema which restricts the data that can be stored in an instance of the database. So, a DBMS enforces the integrity constraints. Let us see what are the kind of things that we can induce. So, these are specified and enforced at different times. This particular restriction can be put either by DBA when he defined the table or when he defined the schema, or else there is another way to put into, that is when a DB application is running, the DB should check for the violations and disallows changes to the data that violate the specified integrity constraints. So, in this way you can induce the integrity constraints in the form of two ways. For example, no two students have the same student ID, as I was talking about. no two students have the same student ID value. So, while defining the database schema in the student table, I had told that this field is having an integrity constraint. What is that constraint? No two students should not have the same student ID value. So, that is the constraint I am putting at the time of DDL, data definition language, or else in the running time also it can be verified. Suppose if some person tries to put the same student ID for different students, it should restrict. So, in this way you can enforce the integrity constraint in the tables, or else another example you take, no two employees can have the same social security number. So, each and every employee will have only one social security number. While defining the database, or else while defining the the column in the table, you have to put that particular restriction to be into the table at the time of preparing that query. So, another example is no two citizens of India can have the same Aadhaar card number. So, this is another kind of example that we can quote over here. So, in this way we can give the integrity constraints in the tables. Then comes the key constraints. A key constraint is a statement that a certain minimal set of the fields of a relation is unique identifier for a tuple. A tuple is nothing but a row. In order to identify each and every row, there should be certain minimal subset of the fields which can identify a row uniquely. For example, if employee number is there, so employee number column or attribute individually identifies the records in the employee table. So, it is called a kind of a key constraint for the table. So, likewise you have several key constraints. One is super key, candidate key, primary key, foreign key, composite key, alternate key and secondary key. So, there are here we had listed altogether 7 kinds of keys. Each and every key differentiates with the other keys in the way it functions in the table. So, let us see one by one what exactly is a super key and the other keys. Consider the relation. Before we move on to the definition of the super key, just watch the relations, two relations, employee and the department relations. Here in the employee relation, we had identified 5 attributes: employee number, name, address, department ID and then salary. And in the department, we had identified department ID, department name, manager ID and then location ID. So, remember these particular 2 relations wherein which we will be working with throughout in order to identify which is like which combination pertains to which key. So, here you can see E number we had underlined and department ID also we had underlined, please remember, and let us move on to the definition of the super key. A super key is a set of one or more than one key that can be used to identify a record uniquely in a table. So, it can be a single key or else it can be a set of keys. So, the combination we call it as a super key. The only thing that it has to do is it should identify a record uniquely. That is the only thing that it has to do. Either it may be using one key, either it may be using a set of keys, more than one key, then it is called as a super key. So, under this super key, the primary key, the unique key, alternate key comes into this particular category. So, all these 3 keys are nothing but the subset of the super key. So, super key is the superset wherein which it has several kinds of combinations available in order to identify unique record. So, let us see a table can have many super keys. Let us see with the help of an example. We had seen the relation over there, the employee relation over there, wherein which that particular employee, here it should be just see here it should be employee table, not the student table. So, employee number is one way or else one key wherein which we can identify the each and every record uniquely. Or else let us take another set which is called as employee number and employee name, wherein which this combination can uniquely identify a record in the employee table. Or else let us take another combination, employee number and employee address. So, this combination also identifies the records uniquely in the table. Likewise, we had defined 7 sets. So, this particular combination or this particular complete set is called as the super key set, which is the superset of all the keys, and any combination shown above can identify the records uniquely will be a super key. So, this thing you please remember so that we can carry on forward. Why? Because we will be using the super key keyword in the other discussions also. So, let us talk about a key called as the candidate key. It is a set of one or more fields or columns that can identify a record uniquely in a table. Once again, it is something or else nearer to the definition of the super key. However, there is a restriction. There can be multiple candidate keys in one table. Each candidate key can work as a primary key. It can be defined as minimal super key or irreducible super key. So, this is the variation wherein which we find in the candidate key when compared to the super key. So, we have defined 7 set of super keys. However, the minimal super key which defines or else which identifies a record uniquely, that irreducible super key is called as a candidate key. So, employee number or else employee name and address. So, this particular 2 sets we can call them as the candidate key. Why? Because with the help of employee number we can retrieve the record uniquely, or else other than the employee number, suppose if you take the case of employee name and address, this combination also can be used in order to retrieve the record uniquely. So, both these keys are called as the candidate keys. Then comes the primary key. Primary key is a set of one or more fields of a table that uniquely identify a record in database table. It cannot accept null or duplicate value. So, this is where the variation lies between a candidate key and once again the primary key. It cannot accept a null value as one of the value in the field. So, it cannot also accept the duplicate values. So, if at all there is a field wherein which it does not accept null, unique and does not accept the duplicate values, that key can be identified as the primary key for that table. Only one candidate key can be a primary key. In the example of candidate keys, you can see we had used 2 combinations. One is employee number and the other is employee name with address. So, we can hide out that particular employee name with address and we can take employee number as the primary key for the employee table. Hope you understand the difference between a super key, then a candidate key, and how a candidate key is different from the primary key. Then let us move on to the next key called as the alternate key. An alternate key can be any of the candidate keys except the primary key. In the earlier example, among the candidate keys, employee number and then the second set is employee name with the address. We had taken out employee number as the primary key. So, the leftover key, candidate key is the employee name with address. So, that particular employee name with address can be an alternate key. Then comes the foreign key. Sometimes the information stored in a relation is linked to the information stored in another table. In relational database management systems, we enforce the integrity or else referential integrity in the form of a foreign key. Foreign key is nothing but if you have one relation to be modified and it is appearing in one of the, like one field is appearing in one of the table and the same field is appearing in the second table also, and there we had identified as primary key in the first table and the same key as secondary key or else foreign key in the second table. What is the reason of identifying a foreign key? This is nothing but we are trying to provide a kind of relation between the two tables, wherein which once the information is updated in the first table, if at all it is lying in the second, the same data item is lying in the second table, we want to update it automatically. So, no need of applying twice a query on each and every table. This may cause data redundancy also. So, that is the reason why we link up both the tables containing the same field in the form of a referential, by inducing the referential integrity. A foreign key is an attribute or combination of attributes in one base table that points to the candidate key of another table. Let us take an example over here. There are two relations, one is employee relation and the department relation, and in the employee relation E number we had identified as the primary key, and in the department relation we had identified department ID as the primary key. So, you can see over here in the employee table you have a field called as department ID over here. Why we are keeping that field means we have to specify in which department the employee works, and you have another relation called as a different relation for the department. So, here whenever the department ID changes, suppose whenever the department ID changes, suppose if you want to change the department ID number, then obviously the field existing over here, it reflects the same change. So, in that way we can like induce the referential integrity constraint in the form of a foreign key. Another key is there, but it does not have any prominence. However, we can like remember in the form of a composite key. The composite key is nothing but it is composition of many keys. It is a combination of more than one field or column of a table to form a candidate key or a primary key. Earlier we had seen employee name with address, that is nothing but a composite key. Employee E number with address, that is also combination of composite key. Likewise, whenever we are combining two fields, then we can call that particular key as a composite key. Next, another key is there called as the secondary key. The attributes, those are not the super keys, but still can identify the records, are called as the secondary keys. Here the basic difference between the super key and the secondary key is nothing but super keys uniquely identifies the record, and the secondary key, however, they may retrieve the record, but they may not retrieve the uniquely records. Any key like e-name, with the help of e-name also you can retrieve the record. Suppose if Srinivasan is there, so there may be existing several Srinivasans in the employee table. It may be pointing out to the one person or one particular record, however that is not the record that we are searching for. So, likewise address also, Delhi. So, in the address field there may be Delhi occurring several times. So, whenever it points to some sort of Delhi, that may be not the record that we are trying to access. So, likewise the secondary key helps in retrieving the records, however not uniquely. Then unique key. The basic difference between this unique key and the primary key is nothing but unique key allows one field as a null field, but there the primary key does not allow the null values or the duplicate values, but here unique key allows one of its field as a null value, and it cannot have the duplicate values. So, a primary key is unique. This acts like a primary key, but it can accept a null value and it cannot have duplicate values. That is the basic difference between the primary key and the unique key. Then let us come to the other constraints called as the functional dependencies. A functional dependency describes a relationship between attributes within the same relation. Here we are talking about the same relation, not with different relations. An attribute is functionally dependent on another if we can use the value of one attribute to determine the value of another. With the help of this example you can understand. suppose if a relation contains employee name as well as the social security number. So, SSN, social security number, we are identifying it as a primary key, and in the same relation you have the employee name also. So, whenever you want to retrieve the record with the help of SSN number, obviously the record can be retrieved. However, you can see over here, SSN number can be used to uniquely determine the value of employee name. At any point of instance, suppose if you want to retrieve the employee name directly, you can give the SSN number, so that automatically the employee name can be retrieved. Likewise, suppose SSN number is given and then the pay needs to be retrieved, then also you can do. So, this particular field is acting just like it is determining the other field also. And the way we have to interpret this is using an arrow symbol. So, X forward arrow Y, and it can be read as X functionally determines Y. Here I can interpret X as SSN number and Y as employee name. SSN determines, functionally determines employee name. So, in this way we can write the functional dependencies. And then another example, student ID, course number, semester functionally determines grade. And then course number, section functionally determines professor, classroom and number of students. What you can observe over here is, in these examples, in the same relation student ID and student major are existing. Likewise, in the same relation student ID, course number, semester and grade are residing. In that particular column, one field is functionally determining the other field. So, this particular thing is called as a functional dependency. So, with this, before concluding this session, let us have a recap. In the start of the session, we had talked about the relational schemas, database schema, and then various key constraints that we can put at the time of defining the tables or at the time of running of the database. We had seen various key constraints like the super key, the candidate key, primary key, and then several keys. Along with that, we had learnt what a functional dependency is and how it affects the tables or else the database retrieval and the other things. With this, I conclude the session. Thank you.